All right, so this is the concept development portion of Module 4, Lesson 15. I can multiply non-unit fractions by non-unit fractions. And in this one, we're going to look at problem 1. And you'll see that right away we have a non-unit fraction. Now, a non-unit fraction is a fraction that has any number as the numerator besides 1. So we have a 2/3 and a 3/4. So I want to remind you of last week. Remember last week we talked about what is 1/3 of 3 bananas. So we said, well, if we have 3 and we're only looking for 1/3 or 1 out of 3, remember that can also be an out of sign, then the answer would be 1 banana. And then remember I switched the units. I said, well, let's not call it bananas. Let's call them fourths. So if we called them fourths instead, the answer would still be 1/3 of 3/4. It would still be the same as when we called it banana. It would be 1/4. So this week, we're going to be taking it outside of the unit fraction of 1/3. And now I'm going to ask you a question such as, what about 2/3 of 3? Well, let's go back to banana. 2/3 of 3 bananas. 1/3 of 3 bananas was 1 banana. So 2/3 of 3 bananas would be 2 bananas. Okay, now again, let's go ahead and switch these to fourths. Let's call it fourths instead of bananas. I'm sure you would still probably agree with me that 2/3 of 3/4, not bananas, would be 1/4. 2/4. So the answer would be 2. We would call them fourths. We write it as a fraction like this. And 2/4 is also equal to 1/2. So now when I come back and I show you how to do this using the rectangular fraction model, the way we can figure out what is 2/3 of 3/4, we're going to start with of 3/4 because when you're doing something to something else, that means 3/4 is where we start with. So I'm going to draw a rectangular fraction model and I'm going to break it up into 4/4. Okay, and then I'm going to shade 3 of those 4s. 1, 2, 3. Now, what the question's asking me is asking me what is 2/3 of the 3/4. So I'm going to break this now into 3 equal parts. I'm going to go horizontally. So now I have 3 equal parts going this way. 1, 2, 3/3. Now, how many of those am I going to shade? 2 of those thirds. So I'm going to shade. And I could shade here too, except where there's nothing there, so it doesn't matter. That's an empty spot. I couldn't, it wouldn't mean anything. So I'm just going to shade the ones that are already representing a portion of the 3/4. So this right here represents the 2/3, and this part right here represents the 3/4. So you're finding what is 2/3 of 3/4. Now go ahead and count out how many equal parts are in each, is the whole made up of, and you would get 4, 8, 12. How many are double marked? You would get 1, 2, 3, 4, 5, 6. 6 12s. Now if you reduce this down, you'll also get 1/2 as we did before. What you'll observe about problem number 2 is that you are multiplying 2/3 by the same fraction 2/3. So how we would draw that as a rectangular unit or a rectangular model is we would break. I always start with the second fraction first because we're taking 2/3 of. Remember, this multiplication also means of 2/3. So I'm going to break it into 2/3 like this. Into thirds like this. I'm going to shade 2 of those thirds right there. And then I'm going to turn around and I'm going to break it into thirds horizontally. And I'm going to shade 2 of the thirds right here. So I have 2/3 of 2/3 shaded. So now how many do I have double shaded? I have 4 double shaded. That's your numerator. And then the denominator always tells how many parts the whole is divided into equally. So that's 1, 2, 3, 4, 5, 6, 7, 8. That's 4/9. All right, so let's go ahead and look at problems 3. So problems 3, A, B, and C have something that I want you to pay attention to. Look at this denominator. You got a 9 and a 7. If I was to break and draw a rectangular model and break my rectangular model into 9 going this way and then 7 going this way, or vice versa, I'm going to have a lot of squares and I'm going to have a headache. So I need to find a more efficient way to do this problem. So how I can do this problem is not anything different than something you've already learned in the past. It's how to set it up where you're saying 7/9 of, which means times, 3/7. Once you have this set up, what you're going to do is what we've done before. We're going to look for cross-canceling opportunities. So we're going to look this way, sideways, diagonally one way, and then diagonally the other way. So is there a number? Let's start with the blue line. Is there a number that goes into 7 and 7? Well, yes, obviously 7 goes into 7 and 7. So we're going to cross that out, and our new denominator on this side is 1, and our new numerator on this side is 1. Now we're going to look at the other diagonal cross-canceling, and is there a number that goes into both 3 and 9? Yes. You can divide 3 by 3, and you can divide 9 by 3. 3 goes into 3 one time. That's our new numerator on that fraction, and 3 goes into 9 3 times. That's our new denominator on this side. So to clean this up so you can see it more, it's your 1 times 1 over, because here's the other one, over your 3 times, and then this is the other one, 1. So when we multiply fractions, we multiply across. 1 times 1 is 1. 3 times 1 is 3. So the answer to this problem A is 1/3. Problem B, is it going to be an efficient use of my time to draw 10 by 9 parts in my whole? No, it's not. So I'm going to set my problem up just as I did before, where I say 3/10 times 5/9, and then I'm going to go straight to looking at cross-canceling opportunities. So cross 5 and 10, let me check that in a minute, and then 9 and 3. So let me go ahead and ask myself now with that 5 and 10, do I know a number that I can divide 5 and 10 by that goes into both of those? Yes, I do. 5 goes into 5 and 10. 5 goes into 5 one time. 5 goes into 10 2 times. That's my new numerator and denominator. I'm going to come over to my 3 and 9. Do I know a number that goes into 9 and 3? I do. 3 goes into both 3 and 9. So 3 goes into 9 3 times. That's my new denominator on this side. 3 goes into 1 one time. That's my new numerator on this side. So to clean that up for you, what this is saying is 1 times 1 over 2 times 3. And then when we multiply across. That's 1/6. So our answer up here, we can write down as 1/6. And that saved us a lot of time for drawing all those squares and, figuring out 3/10 of 5/9. Okay, let's go ahead and look at C. 5, do I want to draw 8 rows going this way and then 15 columns going this way? That's too much work. I'm not going to do all that. So I'm going to set up my multiplication to look for cross-canceling opportunities. 4/15, and now I'm going to highlight that way, and I'm going to highlight that way, and I'm going to look to see if any numbers go into the yellow ones. I know that 4 goes into 4 and 4 goes into 8. So let me do that right now. 4 goes into 8 2 times, 4 goes into 4 one time. I circle it so it stands out to me. And then I know that 5 goes into 5 and 15 goes in one time up here and 3 times here. So to clean this up for you, we have a 1 times a 1 over a 2 times a 3 again, which equals 1, 6 again. So the answer to C is also 1, 6. Okay, problem number 4. It says Nigel completes 3/7 of his homework immediately after school and 1/4 of the remaining homework. Let me just highlight that real quick, or maybe not cross it out. Let's highlight it because that's important. That's an important word to remember. And 1/4 of the remaining homework before supper. He finishes the rest after dessert. What fraction of his homework did he finish after dessert? So let's go ahead and set this up using a tape diagram. And we know that he has his total homework is the amount right here. And it says that he completes 3/7 immediately after school. So let's go ahead and break this up into 7 equal parts. 1, 2, 3, 4, 5, 6. We have 7 parts. 7. And 3 of these represent the amount that he did immediately after school. And that's 3/7. Okay, then it says, and 1/4 of the remaining homework before supper. So we need to figure out right here what 1/4 of the remaining homework is. 1/4 of the remaining homework. So do you know what the remaining portion is? This is the remaining, right? So we have 1, 2, 3, 4 out of 7. So we are looking for what is 1/4 of 4/7. Well, you could draw a rectangular prism right now, or a rectangular model, so that you could solve this, or you can do it a little bit one of the faster ways, and you can just look for some cross-canceling options here. I know that 4 goes into 4. 4 and 4 can both be divided by 4, so we're going to turn these into 1s. But 1 and 7, that's about as far as it goes. So 1/7 is what 1/4 of 4/7 is. And it says, and 1/4 of the remaining homework before supper. So he did 1/7 before supper. So we're going to take that 1/7. These are already broken into 7ths. We're going to call this before supper. So let me shade this part right here, and I'll even label it right here, 1/7 before supper. And then the rest, and then the following part, the question part of this is asking, he finishes the rest after dessert. What fraction of his work does he finish after dessert? So here we have the rest right here. Well, that's 3/7 that he had left. So your answer is 3/7 is the work he finished after dessert. All right, good luck with your homework on your problem set, and I'll see you soon.